So with that out of the way, let's talk about math. This is how I know I am among my people. Because for a lot of, I don't want to say normal, but for a lot of people who are not in this room, the word math evokes a lot of unpleasant memories of graphing lines and solving for x and doing word problems. For some reason, people really hate word problems. Now, in my experience, when people make this face and rant about how much they hate math, what they're usually talking about is algebra. And I can see where they're coming from. In high school, I used to come into algebra class with 3 or 4 fantasy novels in my backpack. And I would go in, I would sit down at my desk, I'd pull out my algebra textbook, I'd prop it up on my desk, I'd reach down and grab a fantasy novel and stick it inside and read that. And then a few times throughout the class, the teacher would walk around, and as he walked by, he'd just grab the book and take it with him. I'd reach down into the backpack for the next one. Eventually, he started making me leave the backpack in his office, and then I dropped out of high school. Take that, Mr. Rowell. But about a decade later, I went back to school for a computer science degree, and I was really excited to learn more about programming, but I was not looking forward to all of the math, because at that time, I thought algebra was math. But as it turns out, algebra isn't math. Rather, it isn't all of math. Or to use math to make my point about math, algebra is a proper subset of math. Math has all this other cool stuff in it, like Fibonacci spirals and fractals and hexaflexagons and my personal favorite, graph theory. When I finally encountered graph theory, I was so pissed that I had wasted my time with all those fantasy novels. What I eventually came to understand is that math is a language, and algebra is its grammar, which means that the algebra textbook that I was using to conceal my Piers Anthony habit was the Dick and Jane of math. Now, this is not to say that it wasn't important or valuable. If you don't know the grammar of a language, there's almost nothing you can say in it. And books like this are incredibly important when you're learning. But once you've mastered grammar, you probably don't give it much thought. Which brings me to the title of my talk. I am a big fan of the Ruby Rogues podcast. I see at least 2 of you out there. And so I'm going to channel Josh Susser and define my terms. In addition to the Ruby Rogues, I am also a fan of Aaron Patterson's presentation slides, and so for those of you who share that affliction with me, here you go. Fluency. Fluency can be thought of as what you can say when you're not thinking about how to say it. Another way to put it is what you can say when you're woken up in the middle of the night with a flashlight in your face. And this sounds traumatic, but what it's really talking about is what you can do when you're under stress. I don't know about you, but stress makes me stupid. When I'm under stress, original creative thought goes out the window. I'm really unlikely to try anything new. And instead, I fall back on skills I've already mastered, regardless of how effective they may be. And for the record, this is not my cat. I am not this fast with my camera. There's an organization in Portland called Language Hunters, and they use a really interesting model to talk about levels of proficiency. This is not the Dreyfus one that Katrina was talking about earlier, but it has some similarities. Level 1, they call Tarzan at a party. Words, simple phrases. Level 2, going to the party. You can say complete thoughts. You know more words, but it is still hard to talk about some things. Level 3, discussing the party. Now you start having some more interesting conversations. And level 4, Charlie Rose, confused me because I'd never heard of Charlie Rose. I had to consult Wikipedia, and it told me that he is a journalist and has a talk show on PBS, so presumably he has a very sophisticated grasp of the English language. What I like about this model is that it's not all or nothing. You can level up in it over time. And remember, fluency isn't what you can say, period. It's what you can say without having to think about it. So if you're fluent at level 1, you may be able to operate at level 2 some of the time. You just have to work at it. So maybe earlier in the day, I got out my transit map and a notepad, and I asked somebody how to get to the party. But once I've been there for a while and I'm ready to go home for some introvert time, it's taxi, home. As for refactoring, here's a definition I swiped from refactoring.com. A disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. I really like this first word, disciplined. It makes me feel like I should bow or have honor. You're welcome, Buffy fans. I've heard people use the word refactoring to describe an extremely wide range of software development activities. Taking a couple of weeks, breaking some stuff is not refactoring. This is what I like to call doing it wrong. Most refactoring steps take less than a minute. Some of the more involved ones may take 5 minutes tops. And breaking stuff, by definition, is not refactoring. And I deliberately sped through that first part, but you might, so I intended you to miss the last phrase, which is without changing its external behavior. As Katrina Owen said in her wonderful talk, Therapeutic Refactoring, tests are implied. This also means I'm hand-waving them and not going to talk about them very much. Tests detect and warn you of changes in behavior. Using them to verify your work makes it possible and even fun to experiment with different arrangements of your code and see which one tells the best story. Now, I have no doubt that every word in this definition was carefully chosen, but there are a lot of them. So how can we make that last part stand out a little bit more? Here are the words in it that I think are most important. And if we drop all of the rest of them, we get a technique for restructuring code without changing behavior. So that's refactoring. As for what it means to refactor, well, we can make a verb out of the noun just by dropping a few words, and we get to restructure code without changing behavior. I think this tells the same story with fewer details. And that, to me, is the essence of refactoring. It's about making your code tell a clearer story with fewer distracting details. I would also like to propose an alternate definition of refactoring, a language that describes ways to make your code suck less. Because we all know our code sucks. But more importantly, if refactoring is a language, then we can apply that language hunters model that talks about levels of proficiency. It's no longer an all or nothing thing. No. There we go. If you were interested enough to come listen to this talk, and I'm glad that you did, you're probably already fluent in refactoring, even if it's only at a basic level. You can become more fluent in refactoring. This one is easy. You can become more fluent in anything. It just takes practice. And putting in the practice to become more fluent in refactoring is worth it, because you'll be able to say more things when you're under stress. And remember, language is the refactoring of making your code suck less, and who doesn't want that, right? So I'm going to tell a story about some code that I encountered in the wild. And because I was the person in the story, I'm going to tell what it was like to go through this at my own level of refactoring fluency. If you're more fluent than me, then I look forward to hearing later about how I can improve what I did. And if you don't catch everything, it's okay. Take in what you can. Trust me on the rest. And there will be video. I'll publish the slides. And I will put the code up once I get some sleep. So this code comes from a production Rails app. I got permission from its owner to use it in public, as long as I changed the identifying details. And while I am going to tear this code to shreds, I do have a lot of respect for the developers who wrote it. They were under a lot of pressure from the business at the time, and like all of us in that situation, they did what they could with what they had. Also, I've written much crappier code than this. As for what the code actually does, this is almost irrelevant because refactoring is concerned with how your code is structured, not what it says or means or does. But just to provide some context, we'll say that it comes from a cable company and it's used to schedule installations for new customers. Here's our test subject. I'm deliberately using a tiny font here to emphasize the shape of the code. I was showing this to a coworker of mine yesterday who'd never seen this, and he looked at it and he goes, "I can't read it, and already I hate it." I will zoom in when the details become important, but even from here, we can make some very basic observations. There are about 800 lines of code in this file. About 50 of them are right here in this method. The longest line is a whopping 177 characters. The indentation ranges from 4 to 16 spaces. That's that nice little arrow pattern. And that indentation comes from nesting various control structures. There's a couple of copies of this audit trail for method that takes a block, a couple of begin, rescue, end stanzas, and a whole lot of if statements. Now, I have a theory that once code reaches a certain level of complexity, it tends to get worse. If it's hard to understand everything the code is doing, a developer who's working under schedule pressure will make the smallest change that doesn't obviously break anything, maybe run the tests, breathe a sigh of relief, and ship it. I hate this damn squirrel. Here's a little known fact. This image contains a typo. A team of scholars and expert squirrel lip readers have determined that this squirrel is actually saying, ship shit. When you follow this squirrel's advice for too long, you wind up with a problem for waste management engineers. And on that note, perhaps you remember that first observation, which was that there are 800 lines of code in this file. A lot of Rails controllers turn into junk drawers, but at 800 lines, this one isn't just a drawer. This is an entire cabinet full of rusty cheese graters and bent whisks and broken dreams. And my first instinct is to clean all the things. But 800 lines of code is a lot of things. Especially Ruby code. I may not have the time or the energy to deal with the whole mess at once, but here's what I can do. I can make the job smaller. For right now, I'm just going to focus on cleaning up this one method. And as for the other 750 lines in this class, not my circus, not my monkeys. Now, for the part that I am going to fix, I already know from experience that this session is going to involve some swearing, and it's going to take me a while. So what I'm going to do is a little prep work. I'm going to walk over to the cabinet of despair. I'm going to take that junk drawer of broken dreams right out of it, and I'm going to set it down in the middle of the kitchen floor. The formal name for this process is replace method with method object. This one's in the book. It's also in Katrina's talk, but it's not something you use every day, so here's a quick overview. This is the Rails controller action. I have folded up the entire method body. The first thing I do is create a new object that's named more or less after the original method. I take the entire body of the method and move it out into the new object. Then back in the original method, which is now empty, I create that object and invoke it. That doesn't actually work yet because the code that I just moved over has a bunch of calls to params and render and redirect to because it was in a controller, so I have to pass in a controller to this thing. At this point, I have a choice. I can go through the transplanted method and I can add @controller dot at the beginning of everything that is raising a no method error, but that sounds a lot like work. So I'm going to take door number 2 and use method missing. It gets better. I could use delegate. I did that in one of the passes that I took at this code. So now all of those calls are going to get passed back to the controller. So now that I have this junk drawer out in the middle of the floor, I'm going to start picking things up from it from the top layer one at a time, and I'm going to hold them up and I'm going to say to be or not to be, or what is this thing and why is it here? The first thing I see when I do this is an if-else-end structure that branches on request XHR. The first time I went through this, XHR was new to me, but I looked in the docs and I saw that it's an alias for XML HTTP request. So I guess I must be looking at different handling for AJAX requests and everything else, which I guess is HTML. Okay? So I unfold the next layer of code. And I see a begin statement, and then I see something that checks to see if the installation is pending a credit check. If so, it renders and returns. I know what this is. This is a guard clause. I wonder if there's one in the else branch too. So I unfold that. Well, I do see that same pending credit check thing, but it's indented differently. Oh, I see. It's not in a begin end where the other one is. And also, it doesn't appear to return. What the? Who writes this? So maybe this isn't a guard clause after all. And after a minute or two of get blame and swearing, something catches my eye. Way out at the end of this line. There is a return statement after all. So I'll take out the and put the return on a new line. As for the asymmetry with the begin end block, that turns out not to be a big deal. So now that I've identified a chunk of code on both sides that does something, I want to get it out of the way so that I don't have to keep looking at it and remembering what I just went through. So I made a copy of that if-else, and I just moved each of the guard clauses up into the appropriate branch. I'm ready to fold this section up and move on, but when I do that, I see some duplication. Now I've had the dry principle hammered into me. Don't repeat yourself. So I unfold it again, and suddenly I notice that there are two pairs of duplicated if statements, the ones that I started with and the one that I just made. Right now, it looks like no matter what I do, I'm going to have some duplication here. And I'm not sure how I'm going to deal with this yet, but something else about this thing on the top is making my brain all itchy. What I want is for this code to tell me a story. I've begun extracting a preface, but it still doesn't sound quite right. This chunk of code does one thing. If the installation is pending a credit check, it complains to the user and dies. But the first thing that the reader encounters is, hi there. Oh, did you know? For Ajax and HTML, I do different things. Isn't that exciting? And every single time I look at this, that's what I see. So I have an idea, which is to make the condition that triggers the guard clause be the first line of the guard clause. Sounds radical, I know. This is my interpretation of a refactoring technique called flattened nested conditionals. This one's not in the book. I stumbled across it in a Dr. Dobbs article by Michael Feathers. I'm telling you this so that if you need it, you can go look for it later. Here's the theory. There are two conditions here, request XHR and installation pending credit check. To make these slides a little bit easier to follow, I'm going to replace those with two variables, Ajax and pending credit check. And now we have two variables and two chunks of code. Each chunk of code will only be executed with a particular combination of those two variables. Right now, those conditions are implicit in the structure of the code. But as long as we only execute each of those chunks of code under the same conditions, we're free to use whatever control structures we want. I'm going to start small by taking this if-else and turning it into if and if not. Now I have two if statements, each of which has an if statement inside it. I can just AND those conditions together. And now pending credit check is common to both of those, so I can pull it out. This is the inverse of that flattened nested conditionals, but this time I'm taking the other variable and pulling it out to the top. Everybody with me so far? Okay, I see nodding, good. Now I can take those two if statements and turn them back into one if-else statement. And because that return statement is common to both branches, I can factor it out to the bottom. Here's what I started with. Here's where I wound up. These two snippets of code do exactly the same thing, but in the one on the right, the reason for the guard clause is right up there at the top, and the response handling that's inside it is secondary. And in fact, it's so secondary that I don't even want to look at it right now. Because that return statement is now out of the way, I can take that chunk of code and I can extract it out into its own method. At this point, I'm down to a 4-line guard clause, which is about the smallest I can get it, so I'm good with this part. Next up, first time I encountered this code, I spent 3 or 4 hours banging my head on this, and eventually I came up with a terrible hack, which I will now summarize for your entertainment. So let's say I have some code that may or may not raise an exception. I can wrap that code in a begin and an end, and it will behave exactly the same way. If an exception is raised, it propagates up the stack, and otherwise execution continues out the bottom as normal. Now the begin and end look kind of silly without a rescue clause, so I'll add one. But rescuing an exception now changes the behavior of this code, so I have to take that exception that I just rescued and re-raise it right away. So let's say that that code already has some exception handling wrapped around it. And let's say that it has, some weird conditional logic like branching on request type. Now, technically, the rescue clause at the bottom still preserves behavior, but which is to say anything that's raised above, whether or not it gets raised and how, will be re-raised as is below. But I am perfectly free to mirror that same structure in the rescue clause. He's not trying to strangle me yet, so I'm good. So now I can take the exception handling from one side and move it down to the bottom. I can take the exception handling from the other side, and you see where this is going? Move it down to the bottom. Now, this if-else is completely empty. I can delete it. That leaves this rescue clause completely empty. I can prune that. And hey, look, a pointless begin and end. It can go. And this weird, gnarly exception handling code is still a mess. It's the same mess that it used to be. But here's the important thing. It's a mess that only does one thing, and it's by itself, which means I can give that mess a name and get it out of my face. As I kept working with this code, I used this same tactic again and again, which was to take that question of what kind of request is this and push it down just one level of indentation. Then I can isolate the next bit of behavior and extract that into a method. I want to leave some surprises in case any of you would like to play with this code yourself, but I thought it would be kind of fun to do a sort of wide-angle time-lapse of the rest of the changes to this method. If you're so inclined, I encourage you to softly hum the power ballad of your choice. Here we go. Softly. Anybody want to see it again? All right, let's go backward. And forward again. Now, this method is still more complex than I would like it to be, but it's down to the point where I can hold all the details in my head as I read through it, which is a vast improvement. The best part is that request_XHR no longer appears in this method. There's still some more cleanup I can do, but this is good enough for right now. So let's follow that request_XHR and see where it went. All in all, I wound up extracting 5 private methods that all have the same basic structure. Let's zoom in on one of the short ones. If this is an AJAX request, render some JSON. Otherwise, set a flash message and redirect. Now, the main method that I extracted these from mostly talks about things in the domain of the business model. But this code is using words like request, render, JSON, flash, and redirect. And all of those things are in the domain of the controller, but they're still sitting here in this schedule installation class. And now seems like a good time to at least mention a little thing called the single responsibility principle. It's just SRP to friends. We've been working in a class that, for want of a better name, I called schedule installation. But if we were going to name this class according to the responsibilities it already has, it might look something like this. Every and in this name is an SRP violation. And these SRP violations were all along in the original method. Excuse me for a moment. I forgot to get my props out. I was doing some light reading on the plane. This is Sandy Metz's book. And this sentence reached out and grabbed my attention. Methods, like classes, should have a single responsibility. And my reaction on seeing this was a split second of, well, duh, followed by a massive facepalm when I realized that SRP, of course, is defined in terms of classes. And because this says class, we don't think method. So that was kind of a fun realization. Of the 2 SRP violations that we had in the original method and we now have in this class, the bigger contrast is between scheduling and installation and all of this request business. So I'm going to split this class first along that boundary. There are a lot of things I could name this new class, but because it seems primarily concerned with managing an HTTP response, I'm going to call it responder. The responder's job is to bridge that gap between the domain of the web and the domain of the model. Schedule installation does its thing, and when something interesting happens, it just tells the responder, hey, something interesting happened. And then it's up to the responder to decide how to represent that information in the context of the current web response. Now, in the interest of time and keeping everybody awake, I'm just going to do this next bit using boxes and arrows. In the beginning, there was installations controller. And then we extracted a method object called scheduleInstaller and gave it a horrible method missing hack. And now we have this responder class, which is going to sit in between the two. And its job is to translate, hey, something interesting happened, into render some JSON. With that message forwarding in place, I can take all of those methods that I just extracted that are private inside schedule installation, and I can move them down into public methods on the responder class. And now schedule installation is looking a lot smaller, but all I've done now is just move the mess off into responder, right? Here's the shape of the responder class. All of its methods now have this same form. If request is XHR, do this, else do that. This responder has an identity crisis. It's constantly asking if it should do this thing or that thing. Fortunately, there's a refactoring for this also. It's called replace conditional with polymorphism. I take one tool that's designed to solve two problems, but asks you to tell it every single time which problem it's solving, and I split it into two tools. Each of them solves one problem, and then I only have to make that decision once as to which one I'm using. The implementation on this is pure brute force. Copy-paste the entire responder class, change the names. One is Ajax responder, one is HTML responder. And then, more brute force, I just delete all of the HTML stuff from the Ajax responder and vice versa. And now, in boxes and arrows land, instead of having a responder class that was acting as our proxy between the scheduler and the controller, we either have an HTML responder or an Ajax responder. There is no proper responder class anymore. That has been turned into a role that both of these objects play, which means that we have to go back into the controller and tell it which one of these to use. Finally, back in schedule installation, I have to decide, oh, sorry, that's a bug in my notes. We pick which one of these things to use, and that if request XHR has moved back into the controller right where it started, and there's only one of it. This thing is now where it belongs. There are still some more responsibilities lurking inside this code, but I'm going to leave them for you to discover. I found this to be a lot of fun. I hope that you will enjoy it as well. The rest of this is just cleanup. Here are, excuse me, here are some of the things that this code taught me. I began by talking about math because at so many stages along the way, it felt like I was constructing a little proof or applying the distributive property of multiplication. And I think that's kind of fun, but not everybody does. I also wanted to address the anxiety that a lot of people feel about math, because I suspect that refactoring triggers a lot of those same associations, and it makes people feel like they're in high school again and they just want to get it over with so they can go hang out with their friends. Fast characterization tests rock. If you don't know what I'm talking about with this, I strongly encourage you to go find Katrina's talk, Therapeutic Refactoring, and go watch it. She does a much better job explaining it than I will ever be able to do. And when I first encountered this code, it had tests that ran in about 30 seconds, and they had some coverage gaps. And I was up late one night, couldn't sleep, so I spent about an hour and a half going through the process that Katrina describes in her talk. When I was done, I had full coverage that ran in half a second. Going from half a minute to half a second is incredibly liberating, and I suggest that you try it sometime if you haven't already. It's just so much more fluid. I learned to embrace duplication. I think that this is best illustrated by our good friend if request XHR. When I started this, there was one of them. When I pulled the guard clause out, there were two. By the time I was done with the original method, there were 5. And then I moved those 5 things over into public methods on responder, and then I copy-pasted that, and now there are 10. And then right after that, there were 1 again. And it was right back where it belonged in the controller. If I had let the second one stop me, or the third, I don't know, usually most of the time I practice the rule of 3. The third time I see something, I remove the duplication. Or if I'd let the 5th one stop me, or the 10th, I would have been stuck. But sometimes, I just went with it, and it led me somewhere interesting. Sometimes duplication tells you that you're getting somewhere. Embrace evil hacks. The exception handling code in this example is probably the gnarliest one that I personally have ever seen. Sometimes putting an evil hack in is the right response to code like that. Making the job smaller is sometimes the first step to making it go away entirely. And sometimes you just need to let ugly implementations stay ugly. But this isn't just tolerating evil hacks. Sometimes it's fun to embrace them. If you have a mustache, twirl it. If you don't, consider borrowing one. Another thing I hadn't expected to learn from this code is that perspective on code matters. Refactoring isn't just moving code around. It is moving code around, but it's not just moving code around. You're examining this thing as an artifact, turning it over and looking at it from all different angles, trying to figure out what it was designed for. Looking at your code sideways or upside down can make different characteristics of it more obvious. There were bugs in here that I did not find until I'd been staring at it for an hour or two. Now, or to paraphrase Douglas Adams, superficial design flaws can sometimes conceal fundamental design flaws. So what can you do to become more fluent in refactoring, whether or not you're a Buffy fan? You could start with the canonical book on the subject, or its Ruby translation, which is slightly less expensive. And there's a catalog at refactoring.com as well. Whichever one you use, keep in mind that except for a few chapters at the front of the book, these are reference material. They're not meant to be read in one sitting. Browse through the listings, find something that catches your eye, and then go practice it. While I'm up here plugging books, I cannot recommend Sandy Metz's book, Practical Object-Oriented Design in Ruby, or Pooter, highly enough. This is all about finding different ways you can structure your code. And this book will help you notice hidden responsibilities and give you plenty of ideas for structures you can refactor toward. But the most important thing you can do to get better at refactoring is to practice refactoring. If you use an IDE, figure out how to make it do an automated refactoring. It can be a lot of fun to very quickly see what different things would look like. But I also recommend walking through the steps yourself a few times in the editor. This will help you develop an intuition for rearranging code so that as you're reading through it, you can see opportunities to change things. Commit code every time your tests pass, even if you only changed one line. If it's only been 30 seconds since the last time you committed and you're already confused, it's often, in my experience, easier to just do a hard reset than to walk through undo buffers in 2 or 3 files trying to figure out what state they were all in when last time the tests were passing. For bigger messes, do not merge the first thing you try. Use the throwaway branch, play around, pair on it with a few different people, show it to a friend, set it aside for a few days, then come back and start over again. And if you do find yourself doing this process of revisiting a particular problem for practice, go ahead and spend the time to write some fast characterization tests. Tests are feedback, and it's really fun and liberating to get that feedback as rapidly as you can. This slide is obligatory. I work at Living Social. We are hiring. There are at least a handful of us here in Texas. I'm in Portland. I do a lot of remote pairing. Doesn't always matter where you are. And if you would like to play with this code yourself, it will be on GitHub as soon as I get around to putting it there. The repo is up there right now, so you can bookmark it if you want to. There's nothing in it yet. And with that, thank you.